Hey everyone, thank you very much for joining me today for this session, putting the sec in DevSecOps. My name is Matt Johnson and I am a developer advocate with Palo Alto Networks. I've been working in cloud security and kind of all things containers since before containers were called containers, with things like Solaris branded zones and platform as a service. I guess I like breaking things in my spare time, a little bit of a hobbyist pen tester. But yeah, I spend most of my time working on securing people's infrastructure as code. Which brings us to today's session. Let's have a look at some of the problems facing DevOps and security. And, once a team is kind of working in that DevOps methodology, what issues do we have integrating security into that process? We're going to look at where some of these issues and some of these security misconfigurations come from during that. And then we're also going to dive into some open source tools and some platforms that can help automate and mitigate a lot of these issues. So let's get started. So the problems facing security in DevSecOps teams. When you have a DevSecOps team, you obviously have this expectation that that team is responsible for the entire life cycle of that project, from the infrastructure to the code to support to everything running on that. And with these kind of smaller teams that can kind of control their own destiny, we see a massive increase in kind of rapid to deploy cloud usage, and we see kind of an expectation of kind of faster, rapider 2-week sprints, for example, with deliverables every 2 week, just quicker and more agile and faster kind of work. And a lot of that is based on the fact that automation through CI/CD pipelines, through automated testing, through automated deployment technologies, is enabling that speed, because that is no longer an individual's responsibility. That just happens when the code is committed, with the test being written, etc., etc. So a very good thing, moving a lot of that deployment effort to automation is absolutely great. The one thing we do see, though, historically, is even though kind of the operations are automated and the pipeline is deploying to production and running tests, and that's great, it's often that the security teams are not necessarily involved in that process. So there will always still be either a lag where the security teams are kind of looking at what has just been deployed and kind of getting around to making sure, was it deployed using our approved images? Was it deployed using our approved patched versions of X, Y, and Z dependencies? Or alternatively, in some environments which do mandate a security review beforehand, you might actually have that beautifully automated pipeline being kind of blocked for a manual action of a security team kind of looking at the changes and signing those off. Either way, not ideal. And even if you do kind of bring in a security advocate directly onto the team, and you could call that DevSecOps, right? You now have a security person on the team as part of that day in, day out deployment cycle. But that security person or that security team embedded into your DevOps team are still not going to have in their head the thousands and thousands and thousands of best practices when it comes to every little bit of infrastructure configuration. Like, let's take, I don't know, an RDS database on AWS, for example. What are the best practice configurations and settings to enable and disable to make sure that is a secure deployment? I don't know that off the top of my head, and not many people do. And if they do for that one product or one topic, they're definitely not going to remember it for all of the CIS benchmarks for Kubernetes and all of the CIS benchmarks for AWS, etc., etc., etc. On top of other requirements that your business might have, like PCI DSS for payment card, industry security, and things like that. So whether you have a security person in your team or not, like, DevSecOps isn't really just about that. It's about making sure we can automate as much of these kind of security checks and balances as we would expect to automate with our coding tests and integration tests and unit tests as part of that regular kind of DevOps pipeline anyway. And with that, these teams are working harder. often when you are looking at building infrastructure, that's not really the important thing, right? The important thing is getting your code deployed. So a lot of times the infrastructure is just something that needs to be there. And obviously by using automation and having a CI/CD pipeline, then we have to be using infrastructure as code, because we have to have a way of declaring to our build pipeline, we need these VMs or these containers or these Kubernetes clusters, these S3 buckets, etc., etc. And so often the infrastructure components for the infrastructure as code come from the internet, like we do with kind of, modules for Python or Go. We're not going to rewrite everything every time we need something. So we often go to the internet for our infrastructure as code, be it Terraform, be it CloudFormation, be it Helm or Kubernetes manifests. And, just like the age-old kind of fake O'Reilly book of copying and pasting from Stack Overflow, there's nothing wrong with it. Code reusage is good, but just like any third-party dependency that we pull into our code base, it's just as important to ensure and validate that we trust the defaults and the configurations of this infrastructure as code, just as we would regular code. And so based on kind of interest around this, we'd already done a report looking into Terraform. We recently published a set of blogs where we basically took every single Helm chart currently available on artifacthub.io and ran it through some infrastructure as code security scanning to see what the kind of default security posture was of a lot of these online available Helm charts. And as we were expecting, you are more likely to get a non-secure by default Helm chart if you just use it off the shelf, than you are something that's actually secure and protecting your Kubernetes cluster and protecting your workloads. The same we found with Terraform modules, for example. So that's just an interesting piece of information as to why we absolutely need to embed security checks and balances in our CI/CD pipeline, even if we are not the ones going, well, I'm not writing any Terraform, I'm not writing any Kubernetes manifests. The defaults that you find online are not secure. And so you have to protect yourself just as you would from any other kind of third-party dependency. And again, like, this isn't unexpected. I'm not saying don't use, third-party dependencies. Obviously, everyone does. Everyone has to. There's just too much code to write it all from scratch. But it goes back to the standard security versus usability problem, doesn't it? Like, these two will technically both deploy something that runs in Kubernetes. The smaller one has absolutely zero kind of security configuration in it. The larger one that doesn't fit on a page has passed all of the suggested CIS benchmarks for a secure Kubernetes deployment. But you can see whether you are getting this from a third party and it's configured to be usable out of the box and understandable rather than secure, or whether you are responsible for writing your own infrastructure as code. It's not just that these misconfigurations come from third-party sources. If you are just starting to, write infrastructure as code for your team, how are you expected to know the extra, 50, 60 lines related to security configuration that go into the right-hand Kubernetes manifest there? You're just not going to have those in your head all the time. And so, again, useful to have something just giving you that extra bit of help and assistance as part of your pipeline. So what can we do about it? Like, what tools can we use to immediately kind of improve our security posture when it comes to infrastructure as code? So the first one I want to talk about is by BridgeCrew at Palo Alto. It's called Chekhov. It's completely open source, and it is a static analysis scanner for infrastructure as code. Basically, it comes with a load of built-in checks against all of these CIS guidelines for Kubernetes, for Terraform, against AWS, Azure, Google Cloud, etc. And it basically allows you a really simple tool to quickly plug into your pipeline or even run locally just to understand an existing code base, to very quickly check what kind of issues you might have in your infrastructure as code misconfiguration. So, for example, this is some Checkov output in CLI mode. We'll show it can do a lot of other style output like JSON for further parsing, and can also kind of do clever things with automating JUnit XML and kind of pretty outputs in your CI/CD pipeline. But let's just have a quick look at this locally for now. I have some Terraform in front of me here. And let's say we go into the AWS directory, and I'll cover where these training resources are in a moment. But if we just do Chekhov and tell it to recursively scan this directory, Chekhov's going to go, it's going to identify that this is Terraform, so it's going to use all the built-in Terraform checks in Chekhov to go and find any insecure issues we might have within this infrastructure as code codebase. So when that comes back, you'll see it gives us things that have passed and things that fail. It's also going to scan for like accidentally putting secrets in code, which might get committed to Git. It's also going to scan any Docker files it finds for misconfigurations there. And what you can see here is a load of recommendations for things that, here's the bit of code, here's the file it's in, and what the issue is. And then for each one of those, we also provide a guidance link to provide, maybe you don't have a dedicated security advocate on the team. This guidance is provided so that we can, let me just open that up for you here. This guidance is provided so that a team can kind of, hopefully understand a little more about what these issues are, what they should do to resolve them, and all that good stuff. So let me just quickly show you one of these. So here you go. For each issue that Chekhov can highlight, we provide this a little bit of context as to what it is and maybe hints towards remediation. And then once you have kind of seen some of those issues, you're aware of what your code base maybe is lacking. Chekhov has highlighted a few issues that need looking at. We have provided some quite in-depth kind of remediation blog posts recently by myself and my colleague Steve that kind of dives into, very much on a Kubernetes theme, both of these, but like dives into, okay, well, you're using a third-party Helm chart, which is flagging up a load of issues. How would you go about improving the security posture of that Helm chart? Or even you're just looking at your own Kubernetes manifests that you've written maybe in-house, and you're realizing they're throwing things up as well. So Steve has done a great write-up on going through each and every Chekhov issue in an Nginx deployment and highlighting how he goes and fixes that. And that long piece of Kubernetes that I was showing on the other slide is actually the punchline from that blog post, showing a fully secure infrastructure as code configuration for an Nginx deployment in Kubernetes. So the code I just scanned in my terminal, which, as you saw, came up with a whole load of issues. And what we can do here is actually say, let's do quiet and compact, and this will only show us the failed issues, and it won't show us any of the lines of code, so we get a nice easier to read output. But you'll see there were a lot of issues found in this code base. And that's because this is a training code base. We maintain a couple of different purposely vulnerable infrastructure as code samples. You'll see here there's a lot of issues. And so one of them is called TerraGoat, and it's intentionally vulnerable Terraform. You would never actually Terraform apply this to a cloud environment because it is designed to be as badly configured, as bad a security posture as possible to use as a training resource. So if you did want to get to grips with infrastructure misconfigurations and you did want to kind of understand a little bit more about what kind of issues Chekhov can spot and how that would relate to a code base, but you don't want to go straight to kind of looking at your production code base to start with, the TerraGoat project is a good place to start. Or alternatively, for CloudFormation, AWS CloudFormation fans, we have the CloudFormation Go, exactly the same concept, just very, very badly configured infrastructure as code from a security perspective. And then also a shout out to Kubernetes Go. This one isn't maintained by the BridgeCrew team at Palo Alto, but it's an absolutely fantastic resource. It also works perfectly with Chekhov to highlight the infrastructure as code misconfigurations in the vulnerable manifests. So yes, if you're more on the Kubernetes side, definitely check that resource out as well. And then obviously, this is all well and good to kind of get an understanding for your code base by running Chekhov on the CLI. But realistically, this is designed to be in your pipeline. It's designed to be saving your engineers time by highlighting these issues automatically, just as it would if one of your unit tests failed, etc., etc. And so for that reason, we have GitHub Actions for Chekhov. We also have information on how to integrate this with GitLab, Jenkins. Name your CI/CD pipeline. You will very easily be able to add Chekhov to it, and have Chekhov produce an output format which is actually useful to your developers. So you can see here, really, really simple to just add Chekhov using the Chekhov GitHub action to an existing GitHub pipeline. And the idea with that, like I said, is, there's multiple places you can run GitHub. There's multiple places you can run Chekhov. You can obviously run it locally, but it really is ideally done when your security, the rest of your tests are happening. When you make a pull request or a commit into Git or whichever source control system you're using, before the continuous deployment part of your CI/CD pipeline takes over and then actually pushes those infrastructure as code resources to whatever cloud provider you're using. And so that's kind of a whistle-stop tour of, something you can drop in your pipeline today, and it will definitely either highlight things you aren't aware of. So those unknowns become kind of known, unknowns in terms of like things you probably should look at in terms of improving your security posture. But that's not the whole story. We always say kind of defense in depth is important with any security topic. And what we find, even with embedding things like Chekhov into a CI/CD pipeline, the information needed to 100% assess a security issue or a misconfiguration is actually not potentially fully available. You don't have all the information needed until you are close to runtime or production. For example, let's say we have a Terraform or a Kubernetes manifest that actually uses some variables from the destination cluster itself to do some configuration. So let's say it's pulling like a variable from AWS Config Manager or something like that to configure a security rule. Obviously, at the point where you are running Chekhov locally on the code base, or even at the point where CI is maybe running against a pull request, because you don't have access to your production environment at that point, you're just running in your kind of CI in your test pipeline, you might miss that variable turning into a misconfiguration or a wide open security group and things like that. So it is useful to think about a way of not only checking at one point in your pipeline, but a way of kind of checking the same kind of security policies all the way through, including when you're running in production. But also, equally, there's a lot of low-hanging fruit that doesn't require that kind of belt and braces approach. And the complexity of finding a misconfiguration and fixing it early is a lot cheaper. It's a lot less likely to break something. It takes a lot less development time and engineering time if you find something as early as possible in the pipeline. So, for example, if I'm writing some Terraform or some Kubernetes in an IDE like VS Code, and I've not even saved it and I've not even committed it to source control, but I notice it there and then that's insecure, that's a hell of a lot easier to fix than something that's already in a commit or already in a PR or already in production. The further we get towards production, the complexity and risk of fixing that increases. And so for that reason, we also have a Checkov VS Code plugin, which I can, highly recommend. And so this basically takes all of the results that you would see in a Checkov CLI or a CI scan, and annotates them over any infrastructure as code file you have open in VS Code. So I can quickly demo this here. So I have the TerraGoat purposely vulnerable infrastructure as code repo open, and you can see I've opened the S3 file, which contains a load of very vulnerable S3 buckets. And not only does it list the problems down here, but if I highlight a If I highlight a resource here, it will give me all the issues it's found with that particular bucket configuration. And for issues that have kind of a binary solution, like, hey, you've not enabled encryption, this is how you enable encryption, or versioning, for example, we can even offer quick fixes. So if I click quick fix and I say apply fix for securely encrypted at rest, you'll see it's actually going to go and add the relevant Terraform directly in there before I've saved, before I've pushed this into a commit. It's helping me as an engineer write more secure Terraform. And the same is true of the other frameworks. So, really, really useful plugin that actually provides even more benefits than just the CLI, because it can do these automatic fixes. And then if there are things that you need to say, hey, actually, this is okay, we are okay with this being configured this way, it's needed for how the application works, you can also very quickly add automated skip comments, so they're in your source control as to why you're skipping a particular check for a particular resource. And Chekhov in CI pipelines will then also respect these skip comments. So really useful place to start is within VS Code. And then last but not least, kind of putting it all together and thinking about that runtime issue, we extend Chekhov through use of the BridgeCrew Platform. And the BridgeCrew Platform basically allows you to tie Chekhov in all your CI/CD pipelines so that it can consolidate a list of all the current issues on all the current resources across anywhere you're running Chekhov, multiple projects, into a single dashboard where you can sort and prioritize your security issues. But then also by integrating it directly with GitHub or other source control providers. As you can see, we support a lot of integrations to check whether your infrastructure in your cloud provider has drifted from what was in your infrastructure as code, directly scanning source control for you so that you don't need to manually go and edit your CI/CD pipeline. And there's some really cool advantages that come with that. For example, if we have a look in Google Chrome at a repo that we do have integrated, we can see that the BridgeCrew Platform is able to take those Chekhov checks and automatically annotate any incoming PRs either from the public into a project or your own developers, and highlight not only the recommended fixes for things that we can automatically fix, but also provide you right here in the pull request information on severity, which resource, and the descriptions for which benchmarks this is going to fail against. So super, super useful way of providing visibility to your developers in a really kind of low effort manner, just by integrating the BridgeCrew dashboard account with your GitHub repo. And so in closing, I know this has been quite a whistle-stop tour, but I hope you'll check out Chekhov. I hope you'll check out putting security tools into your CI pipeline. Come and talk to us on Slack or reach out to me on Twitter. And yeah, thanks very much for listening. Cheers.